Well, thanks everybody for showing up tonight or today or this evening, wherever in the world you are. It's been a while since we've done an official presentation like this, probably I think since February, so that's about 4 months. So part of what I thought I would start with is just to describe what's been going on for the past 4 months. A lot of the work that I've been doing on the compiler has been about fixing bugs and structuring internals to find cleaner ways to do the things we were already doing. Just continually making the compiler simpler and better at what it does. Because, you know, we're building a language with a lot of features, and those features interact with each other. And if you let too many weird bugs and corner cases stay, then you create complexity in the interactions of all those corner cases with all the other things. So we're trying to smooth it out, iron it out, make it good, not be in too much of a hurry to release it out to people. Well, I don't really need to say more about that. Anyway, so there's been lots of internal restructuring, lots of bug fixes. People who have been tuning in for the live streams we've done in the past couple weeks have seen a lot of that. Although, you know, we went for several months without doing too many of those streams, but you can extrapolate, those of you who have seen those. We've also been doing a lot of work on the Sokoban game, which is the biggest application for the compiler. It's about 77,000 lines of code right now, which is substantially bigger than the compiler. It's not a direct comparison because this number includes whitespace and comments. And generally, when we word count on the compiler, it doesn't, which, by the way, let's do that. Well, let's go. So the compiler is around, 42.3 right now, 42,000. And this 77,000, if you remove the whitespace and comments, is probably, let's say, mid 50,000s. I don't know. So it's bigger than the compiler. And a lot of that is just stress testing the language features, making sure they really work, figuring out what features we need and what the ongoing concerns should be when we move forward and add things to the language semantics. So we have not been adding things to the language semantics really since February, but we're getting to the point where it's time to do that soon. So the plan is that the next demo will have a big feature in it. But today is more about the smaller improvements that we've been doing over these months at the same time that we've been doing all this bug fixing and stuff. The current status is that we now have about 4 people working on the compiler and the game full time. We sort of go back and forth on either of those. Abner has been putting together a bunch of notes on the really old demo videos and some example code and introductory types of materials, for people who might want to learn how to program in this language. And my original thought was that we were going to hold that stuff back until the initial, closed alpha release with a limited group of people. But from I've been reading the temperature on streams and stuff, and it seems to me like people would really like to have some of that just so they can fill in their own knowledge and stuff, even if they don't have the compiler yet. So we're going to be making that stuff available pretty soon. I don't have a specific date on that. It'll be, when we think it's ready, but hopefully pretty soon, before the next demo for sure. Turn on a light in here. I don't know why it's so dim. Sun's going down on me. All right, so let's move on and show some things. The first thing is that, to fill in some very brief context for people for whom this is new and haven't been following along, but also to keep it very, very short because I don't want to bore people who have been following along, right? When you start up the compiler, you actually start up a meta program which has it's a complete program, and it can do anything that you want. It can organize compilation. It can modify the program that you're compiling, and so forth. And there's many demos of that on YouTube if you would like to go back and look. So one capability that we didn't have until now, and it's just that we didn't get around to it, was there was no real way of passing command line arguments to that meta program. It just did what it did, and we would sort of, if we wanted to make the meta program do different things, we would maybe just go into it and change some strings or something. But now there's an official way to pass command line arguments to the meta program. And I'll show what that looks like in the command line in a second. But the way you get them is you just call this routine compiler get command line arguments, and that returns you an array of string. And here we're going to print out what arguments were passed and then what the command line was. And if I run today's demo, it's called demo June MISC. It's going to have a lot of output because that's how we roll. But if I go up here, so you see 0 args were passed and the command line is nothing. So now 0 args weren't passed here, but this is an option for the compiler. It's not an option for the user level. And you want to be clear about the separation between user level arguments and system level arguments, because you don't want ambiguities, right? And so what we do is you just say dash dash and say, hello there, Mr. Creosote, right? Whatever, dash size 300. And anything to the right of that double dash, the compiler does not interpret and the user level does. So here we go, command line, hello there, Mr. Creosote, dash size 300. So that lets you communicate with the meta program, of course, without modifying it, which is a small thing, but really very useful. And so the way we use this in Sokoban, for example, is now when I'm working, I hit the F7 key, for example, to compile it. So there I've just compiled Sokoban, and I can hit F5 to run it. That's not what we're demoing today. But here, my F5 is now bound. It has dash dash x64, which says use the x64 backend, right, which is the faster one. I can say dash s LLVM, and wait, we don't have an LLVM. If I don't say dash dash x64, then we use the LLVM backend. I really should, just for the sake of consistency, do that. But there's also, you can control debug versus release build and all that by putting these options here, and then the meta program will interpret those. Someone is asking, why is there a distinction between the types of arguments? Just ease of use seems more flexible to pass all to both. Because you don't want to have to worry about what arguments the compiler... The reason for the design decision is just that you don't want to have to be confused about what's an argument for you and what's an argument for the compiler, right? So I don't know. If there's a reason why people maybe need to see the arguments before that, then maybe we can open it up. But it doesn't quite seem like the right decision to me. The other thing to know is that there aren't actually very many arguments to the compiler, right? We don't work like GCC or LLVM or Clang in that, those compilers control everything with command line switches. We control almost nothing with command line switches because I don't think that's a good way to do it. We control everything through build options through the meta program, right? Which the thing that's reading these arguments is the meta program and is what has control over those things. And so I don't really feel like there's much utility in passing the compiler arguments to you, and it feels dangerous. But, it's very easy to change the implementation to work either way. The thing I'm just trying to illustrate now is that that works. Okay, so, well, as I've said, we have this compile time execution engine that runs your meta program. And, people were tossing around the idea of using that as a scripting language, because that's essentially what it is, even though it's exactly the same programming language that's compiled. And someone on the team said, hey, why don't we support Hashbang so you can just run this like a script? And I was like, my initial instinct was like, ugh, we don't want to do that. But then I was like, oh, maybe it's a good idea. And I'll explain the rationale at the end of this, but first, why don't I just show how it works? So this file is demo June misc, and at the top of the file, we actually have a hashbang and some stuff, and then some options. And well, if you run this from a Unix-like operating system, then this is where this would be installed, and you could run it as an executable there. The from hashbang argument actually tells it, well, this dash dash starts the user level options, but because this is running from hashbang, the operating system is going to put the file name over here. So pull the file name off and compile that, and then go, right? On either operating system, right, on any operating system, we treat a line starting with hashbang as ignored, right? So that's why I can compile this program. Yeah, you know, and we just skip past the fact that there's this hashbang, and it doesn't have to be the first line of the file. It could be any line of the file as long as it starts at column 0. And the rationale behind that is just, you know, well, maybe you want to be able to concatenate files together without thinking about it or something. You know, that's a minor detail that we may change. So hashbang is generally on a Unix-like operating system how you would make this thing run in the compiler if you click on it or just run it from the command line, right? In Windows, that works differently, and I'm demoing on Windows right now. So in Windows, if I do this kind of thing through file associations. So if I go to our demos folder, I've right-clicked on this earlier and added a file association. Actually, I added it through an external program. And so if I click on this, it actually runs it now. It runs the compiler with an argument that says, hey, pay attention to the hashbang at the beginning and get the arguments from that, right? And so what this actually does is it looks at this up here, and it says, well, let's grab these arguments off and then peel off the user-facing ones and just use those. So I'm saying hello sailor-sleep. And the reason I'm saying -sleep is because so that this window stays up. Otherwise, it would have disappeared immediately. But you see, we're running our whole program here. And I can do that just by clicking on it in Windows, right? So that gives you the ability to write little script-like things that work on Windows or on Linux, and that you can just click or run from the command line, right? So before, to compile this, I was doing all this stuff, right? I can just do this, and it runs now. However, that was the first implementation of this. And by the way, all of this is coming in super hot. This feature was built in the last couple of days, right? And someone is 1 minute ahead of the thing, right? So someone is saying, hashbang on Linux sends everything after the first space as a single argument, which breaks most apps invoked in that way. And yes, that is true. There's a table online. I should have dug up the link. But there's a table of like which Unix-like operating systems treat hashbang in what way, and it's gross. Like they all do slightly different things. It's a very unreliable system in general, right? Like, you notice how you have to have the path hard-coded here. It's because usually this doesn't do path search. And you can get around it by running a thing called env, but then that messes with your ability to pass arguments even more. In general, it's kind of icky. We have not today completely decided whether we're going to encourage people to put arguments here or not. We did an attempt at making that work, which is just if we detect that there's only one argument and it has the string from hashbang in it or dash from hashbang, then we do our own argument parsing where we break that into spaces. But then that's gross because you can't really have quoted file names with spaces or / spaces in here. But then people who are using hashbangs on Linux probably don't expect that, right? Meanwhile, on macOS, this will work fine. On recent macOS, this will work fine, and you'll get separate arguments. But on older macOS, it comes through as one argument, right? So it's gross. And we didn't realize how gross it was till we sat down to do it. So we still support this version right now where we go in and extract the arguments on Windows or on Linux. And the motivation behind that is just to make things work the same way. So you don't have to do a lot of operating system specific things. You can just drag your files over and use them. That said, there is a way that I think is cleaner and works better and doesn't have all this grossness and potential landmines that happen when you use Hashbang. And that is just, well, you can use Hashbang, but just don't really provide any arguments. And we give the arguments another way. And so I have an example here of demo wrapper 1. I actually have 2 of these. But here I'm using Hashbang, and we're just not passing any arguments. But we've added a routine called compiler set command line arguments that sets these user-facing arguments to whatever we want. And so here's some arguments here. It's just an array of string. And we import just enough to be able to do this. So we say, hey, set the arguments and then kick off this file, right? And so with this as a basic template, I can call into some later file with, let me go to demo wrapper 2. With different arguments. Let me line this up because this one doesn't have a comment. But you can see I've just got different arguments on this one than this one, but we're doing the same thing. And so this is how, for example, you could make, some code base that does a lot of work with just different things that you click on or run from the command line that can do that with different arguments or whatever. And you don't have to deal with the Hashbang nastiness because this is well defined and whatever. So this is the way that I would recommend doing it if you want to be maximally robust. But maybe, maybe it's the case that using these arguments is just more convenient or something. We're going to see how it shakes out. Right now we support both. So for example, here I can say demo wrapper 1. And if we scroll up to the arguments thing, we say, hey, the command line was hello sailor -sleep, right? And that's what we gave here. Now, of course, I have this folder over here with some shortcuts in it. And just to show, I can just click on these. So here's demo wrapper 2. And the arguments are wrapper number 2 -sleep. Yeah. So 2 different ways of doing the same thing. The upshot is now that you can go all the way out to the shell and just make things that you can click on or run. OK, so like I said, when we first talked about doing that, my initial reaction was like, yuck, that's kind of dirty, right? But it does solve one problem, right? And the problem that it solves is expanding the scope of what you're able to do without having to use external tools that may change from operating system to operating system, and that you have to have different mechanisms of doing, as people work on the different operating systems, right? The people have to learn how to use them differently in different places or whatever, right? One of the founding theses behind this compiler is that you don't want to do that. You don't want to have these weird tool chains, right? So a language like C++ doesn't specify how to compile itself. It's just a bunch of .cpp and .h files. And so you have to have this whole other system for organizing those and deciding how they get built and deciding how they get put together into a program. And that stuff changes on every operating system. And those changes are a big headache. They're annoying, right? So the whole idea has been, let's make those not be necessary at all. Like if there's some tool that you want to use on a particular operating system, that's great, go ahead and use it. But the language is going to be self-sufficient enough that you can just use it and do the things that you want to do, right? And so now one of the things that you can do is just have shell-like things that you can click on. And that is now all completely spec'd within the programming language, and so it's guaranteed to work, right? To the extent we can, right? I mean, there might be some operating system where you just can't click on things. And then what can we do, right? But, but if you're able to set up a file association, or if you're able to use Hashbang, then this will work. OK, enough about that. Where are we next? Error coloring and lexical ranges. OK, so when I run this, you'll notice before this output that we're seeing, we're actually getting some warnings as we compile. These warnings are intentional. We'll get to the part in a minute that causes them. But you'll see now that our error text is colored, and the thing causing the error is highlighted in a different color. It's more readable than our previous error messages, first of all, due to the highlighting. And second of all, we now have ranges, like a lexical range of a starting character and an ending character of what the thing is that caused an error, whereas before we just only had one character. So we had a weird like pointer that kind of pointed you at where an error was, but would often be, you know, at the end of it or in a slightly confusing place, right? And so now we're starting to put in work throughout the compiler to generate better positioning for these kinds of things, right? So here, the type directive is the problem. So we have type highlight. Here, for example, I'm going to make a few different errors. So here's a polymorphic struct called thingy, which if you're a C++ person, this is our version of a template that takes parameters. So A here is a thingy of 10 float. That's not an error, right? B, I'm going to try make thingy of hello and int, and hello is not an int, so this won't work. Right? And so here we say, well, we give two errors for the same thing, but we say type mismatch, wanted int given string, and we tell you exactly what it is, right? So it's, those of you who have seen the error messages from before this week know that it wasn't quite as good as this, right? Here's one, you know, let's, instead of passing a type, let's pass a number. So, you know, literals as well, we get the whole literal. And for D, what was the error for D? Oh, thinger, right? So it's thingy and not thinger, so we typed it wrong. So it's just, you know, and what I would call a daily ergonomic improvement to your ability to read error messages and stuff. Now, Ignacio started using this, and he said, hey, man, I'm in an IDE where these colors look ugly, right? So you can say dash no color, and you'll get a black and white output. This color is from our own stuff, so ignore those colors. We'll see where those are generated in a bit. But here, now instead of coloring these type directives, we've just got these carets underneath, right? So about colors being ugly or not, you know, I found a very inconsistent ability to use 24-bit color. This shell that I'm using rounds everything off to like 9 different ANSI colors that are all ugly. So color support is relatively limited, but we might add a thing where we have different presets for different IDEs or something like that, or that lets you define your colors, just so you can make something that's not ugly. But this is just to show that the capability is there now, and the error messages are much easier to read than they were. Even if you're using the carets now, right, and you're not using the color highlighting, you still get the actual range of the thing, whereas before it would have been like one caret over here somewhere. It would have been slightly off. OK. With strings, we've added some escape codes and removed some other ones. So I want to go through what the escape codes are. So we've had \E standing for escape for a long time. I don't know if I ever demoed that, but certainly in some of the live streams when I was programming color output, I forgot that we had \E and I did it manually. But we do. So let me go to where we're defining these green normal, red normal. This is the code I'm going to look at now is what's generating this, actually, this color stuff. So we're printing out, I can print stuff in color anytime I want, and those are different colors, right? So we're saying I can print stuff in color anytime I want, and so green goes here, and normal goes here, and red goes here, and normal goes there. So we're just switching colors back and forth, and these green normal, red normal are ANSI escape codes. They start with an escape, ASCII escape, which is that \E, and then some code that is specific to this color encoding, right? So \E is one of the escape codes. Supposing you want to insert an arbitrary hex number, you can use \X, and then a 2-digit hexadecimal code, which is what we're doing here. So this one says this is a test, right? So this is TEST. And here, this whole list of hex codes is printing out hello sailor, right? If you don't want to use hex and you want to use decimal, you can use \d and then 3 numbers. It's always 3 numbers, even if it's less than 100, 3 digits. So D000 is a 0-digit, right? D001 to 100, 101 to 102, 200, et cetera, and then ending in 255. And then because these aren't mostly ASCII numbers, I'm printing the bytes, right? So those are the bytes 012, 64 to 66, blah, 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 255 in hex, right? We printed the bytes in hex. So why do you want to do that? Well, sometimes you want to be very particular about what's in your strings, and this way you can do that. Well, what are some other ways to be particular about what's in your strings? Well, maybe you want to put Unicode in there, right? So just like C++ does, it's exactly the same format. You can say \u and a 4-character Unicode identifier in hex, right? This is, if you've ever looked at Unicode specs, these are like exactly the way that you specify specific characters. Now, UTF-8 or Unicode officially can, how do I say it? Unicode, I'm actually not that educated on the official Unicode spec, but in general, you manipulate 32-bit numbers behind the scenes, and sort of the maximum eventual range that Unicode might get to is considered to be all of that 32-bit space. But in reality, the highest currently defined Unicode value is like 0x20FFFF, or maybe it's 10FFFF. Anyway, it's more than 16 bits. But most of the things that you ever want to refer to are in the bottom 16 bits. So \u is like, yeah, this is one of these things from the bottom 16 bits, and I'm just going to refer to that. U is like, okay, I'm going to refer to something outside that, one of these more rare characters. And for today's currently defined Unicode, we could get away with 6 digits. But we're putting all 8, and so does C++, because the Unicode people are crazy, and they just keep adding stuff, and who knows how big it's going to get. So let's be forward compatible and just have all 8 digits for these rare cases when you need to use U. So this U2022 is a bullet point, and this is an upside down exclamation point. And so we say, I'm ready to make a slideshow with bullet points, right? We outputted that. And then this one is this 8-digit Unicode, which is a Chinese character that didn't fit in the lower 32 bits. This console doesn't have a font for that, but I can prove that that's what it is by pasting something into Google. So I can go here, and I'm just going to paste this into the browser. And you can see that that's a Chinese character, and it's giving me all these Chinese completions. So I don't know what any of this means. But yeah, we actually outputted that character successfully. Now, this is not necessary to use Unicode characters, because, as always, the input file is defined to be UTF-8. So if your editor supports UTF-8, you can just type UTF-8 in directly. So down here, we're using bullet points. It's just in the file, right? And if I'm in Czech Republic and I want to get some tea, I can say this, and I can use all the cool accents just directly in the file, right? And all of that, where's the output? All of that comes out correctly in the output. However, if you're using an editor that doesn't do very well with Unicode characters inline, or if you're manipulating characters that are maybe difficult in an editor. So for example, here are 2 arrows with a 0-width space in between them, because Unicode defines a number of characters that have no spatial extent and no visual representation. And that could be very confusing in an editor. So this is just a way to make clear that there is something there, right? So here's a 0-width space, blah. And you can see in the output that indeed these arrows have a 0-width space between them. Okay, so the full list of escape codes in the language as of today are as follows. There's new line, carriage return, tab. Everyone's familiar with those probably. Escape, right? 0 byte if you want to zero terminate a string for interactivity with C or C++ or any other language. Of course, you could do that with these. You could say X00 or D000, but it just seemed nice to have this little bit of terseness for good ergonomics of interfacing with those languages. Of course, just like C or C++, you can quote your quote, or you can backslash your quote or backslash your backslash in order to interface those. And then there's these new ones that we talked about today. And that's it. That's all of the string escape codes, right? We got rid of some of the weird ones from back in the C days, like vertical tab and form feed, which are mainly there for interfacing with line printers, but nobody uses anymore. So it seemed to me like a good idea to keep the list of escape codes very simple, so you don't have to be confused or thinking about 50 different things, right? Of course, if you want to insert a form feed or a vertical tab into a string, you can just fine, use the hex or decimal value, right? I'm not even sure about tab, frankly, because tab kind of sucks, but people might be porting programs that use it or something, and so we keep it there. Someone's asking, was there a point to \E? Yes, there's these escape sequences that control console properties like color and highlighting. Okay, so let's get to that code that's actually generating those warnings that I said were intentional, right? So if you've watched any of the earlier demos or some of the live streams, you'll know that sometimes we had to use this directive called type if you wanted to use a type in a value slot, right? So let me rewind even one step before that and say, if you come from the world of C and C++, types are only used in those languages in very limited contexts. They're not regular values the way like a number is or a string is. But in functional languages, that's not the tradition. In functional languages, a type is a value just like a number is. And we are adopting the functional language version of this tradition. We have for the entire development of this language, or most of it anyway. But still sometimes, the parser wouldn't exactly know what to expect, whether it's a type or an expression, like a non-type expression. So we had this type keyword to help it along, right? So to illustrate how that used to be used, I've just made this polymorphic procedure. It takes some value that's a type, right? So it's of type. And we're going to instantiate a value that's of the type of whatever parameter we passed in. And we're going to say, OK, the type is whatever, and the default value is whatever. And here we're using our color codes again, right? So we get a bunch of output, like F says the type is S64 and the default value is 0. The type is some polymorph of thingy, and the value is an array of 10 float 32s, right? The type is an expandable array of S64s. Default value is this, and so forth, right? So we're just printing that kind of thing. Now we're passing a type parameter to this, and the parser used to just expect a general expression there. So you would have to say type all the time. And you would get that was annoying, let's just say, right? We reworked the parser and or the semantic system to not require these anymore. So we can do all of these things now without saying hash type, right? So I can say f of thingy of 10 comma float. I can say f of array of int. I can say f of pointer to void, which also looks like take a pointer to a value, right? And all these things, array or pointer, relative 16-bit pointer to int, all these types. This is a very crazy, complicated type. And we get all the values. And we're printing them the same here and here. It's a little weird. I'm not sure why this is not 0. But need to look into that. Anyway, so that's just an ease of use thing. So, that would come into play when you were calling procedures that take types, but it would also happen when you have structs that take types. So, if I had a hash table, often you would make a hash table saying, well, I want to take a string as my key, and I want a pointer to an output file as the values that we store in the hash table. And, well, you used to have to put type there, and now you don't have to do it. You just say pointer to output file, right? Now, the way this works is kind of magic, because the parser, when it sees this, can't actually know if this is a type or a value expression, right? Or a pointer to a piece of data, is what I mean. It can't tell whether it's a type that's constant at compile time or a pointer to a piece of data that's not constant at compile time. So we have to make this determination during the type checking phase, right? We have to wait till we know what output file is, and then we can determine what the type of this whole thing is. But what makes all this possible is that the two sets of cases don't overlap, right? When you want to declare a type that's a pointer to some other type, well, that other type has to be something that's a type that is constant at compile time, right? And it doesn't make sense to take a pointer to something that's constant at compile time. So these representations didn't overlap, and that made that possible. And then for all these other things, mostly it's just a matter of rejiggering the parser so that they work correctly, with a little bit of exceptions there. There's one question of, is this so terse that it's confusing when you look at a program, and maybe you don't know what this is when you look at it? And my answer to that is we'll see, and we can always reverse this if we want. Maybe you have semantic highlighting in your editor that'll tell you if this is a type or not. I think that would be a lot more useful than syntactic highlighting, for example. I think a small amount of syntactic highlighting is useful, but the fruit salad that most editors put up is not useful. But also, I think even without an editor, you can pretty much tell from context what something is. Like if you name your types with capital letters or something as a convention, then you know this is a pointer to a type, and you're fine. Now, we haven't gotten rid of the type directive 100% of the time, and that's because if you're declaring a procedure type, well, a lot of procedure types we would be able to parse. So this is what a procedure type would look like if you got rid of this type directive, right? This we would be able to parse just fine, but the thing is, this thing, if you got rid of the type directive, would just look like this, right? So if I say this, this is shorthand for some procedure where we're not naming the arguments, but that argument is of type int, and it returns void, but you're allowed to omit void, right? So you're able to say just like int. You probably wouldn't do this in a real program, but grammars of programming languages are not about your feelings, right? So this would be, if you tried to take off the type directive, we don't know if this is just a parenthesized expression containing a type int, or if it's a procedure that takes an argument of type int, because we don't have a procedure keyword or token or anything like that. So in this case, and it's the only case as far as I remember that we still use type, it's to say, oh, the thing coming is a procedure type. And we might rejigger the procedure syntax a little bit to make it unambiguous. For example, if you said, well, OK, so the reason we let you do this is because if there's no body, or if there is a body, like you might be saying f is something and there's a body, right? And you don't want to have to say void, right? Or so forth. But the reason we let you not put the argument name is for cases when there's no body, like when this is a parameter to another procedure, right? Or a procedure pointer declaration. And so the idea might just be, well, if it's one of those latter cases where there's no body, maybe you just have to say arrow to something, and if you don't return a value, maybe you return void. I don't know. We'll look into it. But the point is, it's been very nice to get rid of this type directive almost all of the time. It's been nice. And we'll see if it's confusing, but I don't think it will be. Also along the lines of ergonomic improvements, we renamed some of the bake directives. I don't want to go off forever on how these work. There's like 2 entire YouTube demos of at least 2 hours length that tell you how these work. But now if you go back, it might be slightly confusing because they're named differently. So we used to have this directive called bake that would take a polymorphic procedure like this and fix the value of t and give you back a non-polymorphic procedure. Or if it had a lot of variables and you only baked some, it would give you like a less polymorphic procedure back, right? Now we call that bake constants because bake was just a very generic word and it invited confusion. So here, I'm going to say G is what you get from baking constants on F with t being float, right? So we're going to say, we're basically making a new function where instead of $t, we just say float. And then we're going to call that on a float, but also on an integer literal, which, you know, the language semantics are that integer literals will cast to float implicitly. And so, where are we? When we call this, it says x is whatever the value is, and t is whatever the type is, right? So here x is 3.0 and t is float 32. That's no surprise. In this version, x is 5.0 and t is float 32, right? And that's because we baked this as float, right? And we're calling the baked version. Even though that we're calling it with an int, it's not polymorphic anymore because we squeezed the polymorphism out. Now the other version of bake that used to be floating around used to be called bake values. And that's confusing because these are also values. The polymorph variables, you're assigning values to them, right? So this is renamed bake arguments. And, you know, so I can bake arguments of f with x equals hello, right? And so bake constants bakes the polymorph variables, but bake arguments bakes the actual, you know, parameters that you would pass. We might maybe call it bake parameters. I don't know. That's a little bit of a longer word, I think. P-A-R-A-M-E-T-E. It's 1 letter longer. It's 1 syllable longer, too, so that's important. Anyway, so I'm calling h, well, I'm saying h is f baked down, so its only argument is hello. That gives me a procedure with no arguments, right? If you're from the functional programming world, this is a compile time version of currying, right? So it's like we're currying this down and generating a new procedure, but we're doing it at compile time, right? So now I can call h, and when we do that, we say x is hello, and the type is string, right? So that all works the same as it always used to work. We just got less confusing names. Now, one thing that we had overlooked in previous functionality, and that didn't work properly prior to today, actually, is that in this case of currying h, we baked both x and t, right? Because when you bake this argument x, because it's polymorphic, you also have to fix t, or t would be like undefined, floating off in space. So t has to be string because the value of x is string. So, you know, when you do this, it actually bakes both variables, but this wouldn't have to be polymorphic, right? You can do this on a procedure that's not polymorphic, and it works fine as well. This is just a more complicated case. It's a more show-offy case. Okay. In addition to that stuff, why not call it bake types instead of bake constants if that's what it does? Because the constants don't always have to be types, right? In procedures, they're always types. Maybe I should have demoed that. Where are we? So here, because the only things that go into the constants block of this procedure are on the right, and the things on the right are only types. Actually, that's not true. Okay, indirectly. Anyway, here they're types. If you make a struct, like if you go up to this thingy up here, right? Thingy takes an int parameter, right? And you can bake that. And that's not a type, right? So you can bake an integer into that. And in fact, your procedure could take a thingy of 2 variables in the declaration, and you could bake that variable, right? So it's not only baking types, it's baking constants generally. Basically, yeah. Maybe someday we'll do another stream on that if it's worth going into. Okay, people are still asking questions about that in chat. Maybe we'll get to it at the end. There's a new directive to deal with overloads, right? So if I only have a procedure and there's no overloads for it, it's just one procedure, just like you would use back in the days when we used languages that were no overloads, you could just assign the value to a variable, right? And here I'm using type inference, so I'm not being picky. I'm just saying I want factorial, and then I'm printing that, and the result of that is exactly what you would think. Well, it's a procedure, and there's the pointer value of the procedure, right? But if there's an overload, you can't say the same thing, right? It won't work because we don't know which one you mean, right? So if I do this again, it'll be, let me take off the no color. It'll be like, well, you're attempting to assign a variable to an overloaded procedure. You can't do this. Maybe I should tell you where the overloads are, but we don't right now. In this case, we're fortunate they're right here. So in C++ and similar languages like that, the way that you would do this is by using the type, right? You would declare the type of var2, and then the casting would basically do the selection of overloads. And that's fine, but it's very cumbersome to write the types of these things. And they can be arbitrarily complex, right? If you've used C++ and had a procedure taking, two arguments that are templated, one of which is a template taking other template taking a type argument, it can get so bananas that you really don't want to do it, right? So I came up with a thing that's kind of fun, which is this directive called procedure of call. And the way it works is, look, it says, give me the pointer to the procedure that I would get if I were calling abs of f, right? And here for b, give me the pointer of the procedure that I would get if I were calling abs of I. And you, compiler, you work out the types. I don't want to say what the types are. I don't want to think about it. I also don't actually want to call these right now. I just want to get this procedure so I can store it in a pointer in memory or something, right? And you, compiler, do the overload selection and work it out, right? So here we're getting abs A and abs B, and we're printing out those pointers, and you'll see that they are, oh, whoops, I got to run again now that we compile again. These pointers are different from each other because they're the two overloads, right? Now these tell us whether we're calling the int version or the float version, right? So down here, we're calling both of them with an autocast on -1.0. We're calling abs A on autocast -1.0, and abs A is the one that we called with a float argument, right, f. So we get the float version calling abs float, and abs B is the one that we got by calling integer. And so when we do that, we get the integer version, right? So this is a way of not losing the power of being able to easily and briefly talk about procedures once they become overloaded, right? You still can handle them nicely. Now this works on polymorphics as well. And it works on polymorphics with overloads, right? So here's 3 procedures. They're all called poly, so they're overloaded. 2 of them are actually polymorphic, and 1 isn't, but it's still called poly because I want it to be overloaded with the others. And we're going to use procedure of call to sort of give us whichever overload applies to these arguments, right? So here we're going to do one that takes an array as the first argument, so that's going to be this guy. And here we're going to do one that takes a pointer to a string as a second argument. So that's going to match this one because this one takes pointer to anything, right? And the third one is going to be something that takes a string, right? Greeting is a string that we define here, and array is defined here. So we're not actually calling these again yet. We're just saying, give me these procedures. And then, of course, we're just calling them. So we might as well have just called them. But really, you can do anything you want with the pointers. You can put them in a hash table, store them, call them later, pass them off to a library, right? Whatever you want. So, this is just to show that these work. So where are we? So we get polyarray : hello poly A, x is whatever, because we're printing out the value in here. I'm not going to tediously go through this, but you can convince yourself by pausing the stream later that this all worked and called the correct thing. There's some nuance here. For example, when we do polymorphism in general, everywhere in the language, not just in this case, we do a little bit of tweaking to types, right? So, for example, the type of this array, we print out the type of this array down here, and it's an array of 5 S64s, right? It is very specifically an array of 5 things. But when you polymorph a procedure generally, we sort of figure you don't really want it specifically for an array of 5 things. You just want it for an array of things because you don't want to bloat your program out to like 10 zillion procedures by calling this all the time, right? The nuance here is that when we print out the type for the and the value for the type that takes an array, it's actually an array of unknown length, and then when you print out the value, it's 5, right? Because the polymorph system tries to be very not pedantic about what the type is. Now, should you be able to have an override about that? Maybe. There's not a way to do it yet, but eventually maybe. We haven't found a situation in which we care that much yet. Anyway, so this is just all calling all of these. You can have fun in the video later if you want. That is everything that I wanted to show. Wow, okay. So we got through that in just a little bit under an hour. Does procedure of call result in a failure compiler error if it doesn't exist? This may be useful in metaprograms, but wouldn't be strictly needed. It will error. So if I do this and go bleh, right, then bleh. Okay, but in metaprograms, you wouldn't exactly want to do this anyway. You would just look up. In metaprograms, you get messages for all the procedures. So you just look to see if there was one of the name that you wanted. And if it wasn't there, then it wasn't there, right? So that use case is already covered. Will procedure of call give you the same pointer as using bake constants with the same types? Yes, because the polymorphism system deduplicates procedures of the same type, right? And both of these go through the same core system. Anyway, you can invoke procedure of call foo of bar without creating the throwaway variable bar. Well, if what you mean is without a runtime impact, so I put variables in here just because I felt like it, but this works just fine. Like if I want to do this, right, that works. So I just wanted to give you guys a slightly more complex situation. Whoops. And that would certainly generate no code whatsoever in debug or release builds, right? Because there would be no declaration. Here in debug build, you would get a declaration and assignment, but in release build, that would be hopefully optimized out because nobody uses them. But yeah, you just need to put anything in here. It doesn't have to be a variable of any specific kind. Okay, those were the specific procedure of call questions, I'm actually going to end the main presentation here. I'm going to take a 3 to 4 minute voice break, and then we will come back and answer general questions